Thank you so much for coming. My name is Rob Jan. I'm a technical partner manager at Dynatrace, and I know this is the last day, so thank you for coming. And today we're going to be talking a bit about powering cloud modernization. You guys are all here building your applications, moving to the cloud, and what we want to drill into just is about the context of observability as it relates to logs, and we're going to drill into sort of the challenges that we see and talk a bit about the Dynatrace platform. If you're new to that, you'll get some demos along the way as I do my talk. And it's really about kind of addressing this at scale. And so just as a way of starting, we align ourselves also, like you guys, to the WellArchitected Framework from AWS. So there's a lot of pillars around reliability and performance, cost management. And observability is a key component to drive and empower these types of things. So as you're assessing things, there's also obviously data collection and analysis, understanding your current workloads. As you go about, modernizing and changing things, you want to be managing those risks, and especially from an operational standpoint, that you're maintaining your service levels and understanding the consumptions of your infrastructure. So for us, this is also a great framework to kind of align our kind of understanding and think about some of our solution areas around supporting each of these pillars. So you guys might have heard of this term, the three pillars of observability, which is metrics, traces, and logs. This is a very common kind of framework or term that's used out in industry. But for Dynatrace, we see it more than this, because what logs, metrics, and traces need is context. So you'll see here on this bottom row, and we're going to get into this, and I think you'll see it through some of the demos in a minute, that it really needs the understanding of the topology, for example, of which this trace may be taking place. So knowing that this is on this particular node of a Kubernetes cluster, for example, then it spans over to a serverless function, or it spans back to on-prem into a physical host. So understanding that topology is part of the context of the metrics, traces, and logs. Just similar to behavior, what we mean by that little square is the end user behavior. So what is happening to the end user as it relates to logs, metrics, and traces. And then the code. So, if there's a failure rate or response time, it's the code, usually often the case. It could be infrastructure constraints. But, what is the context of a trace as it relates to the code that's actually being executed, and so on. And so if we think about an observability solution, we want not metric, traces, and logs, but also these other aspects that are important to give it context. And then we want the ability to, interact with this topology information and observability data through APIs, which is how we integrate it. And then also support open standards for metrics, traces, and logs as they get evolved through like open telemetry. And then we want to tie this into automating our observability, because manually tagging things, manually setting up the relationships, building things manually with dashboards, we need automation to really enable this thing. And that's true because observability, the demands, these are a whole set of different use cases that we ideally would want to observe it all, right? We want to see the infrastructure 100%. We want to understand hybrid cloud transactions 100%. We want to see, how features are adopted. We want to see, there's a whole list here, right? Security. So in a perfect world, we'd have a perfect observability for all these things. But also underpinning all these things are many different technologies that are changing, right? You're here at AWS. You're in the process of modernizing, going from certain architectures to new architectures. So really understanding that observability as those things are taking place too is key. But transition into but this is a problem because there's a lot of volume of data. There's a lot of variety in the data, especially when, as we get into logs, that's, you'll understand there's a lot of variety in the log formats, but it's just the scale, where the cloud is exploding. I think you guys, could see from our show, at reInvent, from the last metrics I saw, it's a $160 billion industry growing 30-40% a year. It's just growing, right? So we're now talking petabytes of data, terabytes of ingestion of logs, like just large scale. And, we can't continue to do things with dashboards, having even more alerts on everything that's, going wrong in the environment. So we really just need automation, because it's just at a point where it's just too big, too much. And so it's just beyond the human ability. That's where Dynatrace comes in. So a little segue to Dynatrace first, but then we'll kind of show you some examples of what we mean by this. But the platform at Dynatrace was really purpose-built for putting together metrics, traces, and logs into context and bringing them all together. And the way it does it is through a number of underlying technologies, which we'll demo, and it basically puts it into a large repository and puts it in context. And then we layer this on with an AI engine. So our AI engine is also integrated into the platform for the sole purpose of understanding when there's anomalies in metrics, changes in events, and then getting to the root cause through a causation engine. So it's like purpose-built for revealing high volumes of data. And a lot of that data comes from, sources like AWS. So Dynatrace, as you saw, we're a Diamond sponsor. We have a strong collaboration with AWS. We have these, if you're not familiar with these Ready programs, this is where engineers from AWS work with our engineers to kind of basically certify that solution to be a ready solution. And then all these competencies are also vertical and horizontal competencies that really talk about how we're solving use cases together in the given domain area. So then Dynatrace has two basically sources of data. Through an agent-based technology, we're getting full stack compute across all these different resources, whether it's Lambda, Kubernetes, hosts, as well as full integration with all the CloudWatch metrics and logs that come in through all the variety of services that publish those. And so just, if you guys, I don't know, just curious, did anyone stop by the Dynatrace booth this week on the expo floor? A couple of you guys? Great. Yeah, so Dynatrace, you know who we are. We're a publicly traded company. We're global. We have several thousand enterprise customers. We're, I think, up to 3,500 employees now, recognized a lot by analysts. So I think from that perspective, we've set ourselves in the marketplace, and that's all I'm going to say about that. So now we're going to switch into a little bit more of the technical part. But this is something that we hear, right? As I was talking about all these different data formats, all these different large-scale DOG, this is what we hear. People are tagging, and tagging is a variety of both like tagging the infrastructure items, but also identifying attributes and logs, and it can be a very manual process. So people are spending a lot of time. You need a lot of expertise in a lot of cases, taking that talent away to go do this stuff, and it's stealing from the innovation time, and it's just not really scalable. So that's why, and maybe I just want to move into a demo. So what I'm going to do is show 3 different demos, kind of aligning them to the well-architected framework. Kind of started with performance efficiency, just picking on that one. And that the stuff in the orange is right off the AWS website, so that's sort of their definition of what that pillar means. And it's a great resource if you haven't read there's a lot of white papers. You guys are usually encouraged to kind of do the well-architected assessments and to identify risks and gaps. But anyway, what we're trying to show here is how the sort of this integrated observability is really supporting performance efficiency, because if there's a problem, we can kind of go into this troubleshooting mode and really dig into why things are having problems, so that we can also tie it back to the customer experience. So here I'm going to walk you through a demo. I just got to talk through it. As you see, it's already animated. But here, just as a starting point, where people often start is like, hey, I want to look at some logs that are of a particular system that has a problem. So here I'm going to filter into a Kubernetes namespace of production. I'm going to also filter out onto a deployment, which is the front end. And I'm just going to filter on the errors, error type of the log type error. So this may not look too interesting right now. A lot of tools have this, right? So just basically, I got a log, I'm going to filter on it. I could click on buttons, I could type it in. No big deal so far, right? So let me just show you that. And then now the result here is just a particular log row. But this is where I'm going to drill into this and show you what we also picked up automatically. So here's in this case, this is the log string. And what we had with our one agent that was, in this case, on Kubernetes cluster, we have an operator model that automatically sees all the running pods and all the namespaces. We've automatically built into, as the log was ingested, have all these attributes about what that log was. So we can see, not just the content and the error type, but all the actual entities in the full stack of this entire Kubernetes cluster. And all those hyperlinks actually will hyperlink into the screens in Dynatrace to see, that process or that pod or the cluster. So by clicking into the trace of that log, what this was is that log was from this particular trace. So with one click, we clicked into the trace of this transaction, which is a cart checkout, and see what it did. So on the left-hand side, this is the flow from the cart checkout down to another service to another service. This is what took place in this trace. And at the summary level, we can see that, here's the URL, here's the posted method, and then there was a 500 response time back at the top layer. So that's kind of what we see with the distributed trace. But then what we do, it's besides the trace, so that's what these tabs are, we can drill into the code level details. So we now see what was happening in the code for this trace as it was executing on that particular level. So this is now where that log message got generated. You can see right there as I highlight it. So if I go in the logs tab, these are the logs associated with that specific trace on that particular transaction, all in context. So this is all out of the box. You just install the one agent, you get this automatically. There's nothing you have to do. And so if we look at the individual log, it's the same metadata is kind of integrated into this log row, where all of that entity information, all those hyperlinks back to the underlying cluster, pod, service. And the same thing would be true if it's a physical host. The same thing would be true if it's Lambda. Whatever the underlying was that generated this, you'd see that here. So all of these attributes are then what you can use in your log filtering and your queries, which I'll show you in a minute. And so the last thing in this short demo is you can see here there's a button, View User Session. And so now we're bringing it back to the context of the user. So here, this user came in, and we have what's called a session replay. So for the session of the user, this is all captured, and we can play back what was happening for this user in this session, which will lead up to that particular error. So here you can see as it's animating it, it's going through a shopping cart kind of process, looking at some stuff, put them in my cart, fill in my address and billing information, and then eventually it's going to come up here, as you see the red on the top, that's going to be where the user had a problem. They tried to place this order, and then it's going to blow up, basically, right? So here, it's also another problem where the end user was presented with the full stack trace, but now you can see this is what the user saw. So you saw this backend log with this whatever, but this is what the user saw. And so that's, the linkage. So now, if we go back to the summary of this particular chart, we can see this is the user, the browser, where they came in from. These are all the actions. So there was page loads, there's actions on the page itself, and that's what we're seeing on that left-hand side. So this is all being captured as what we call user experience monitoring. So we see everything that's happening on the browser side, every single click, every single action. So if we drill into that cart problem, we see all the breakdown of the page, browser times. It's kind of maybe hard to see that, but that's what's happening there. So we can see sort of what was happening. And we've classified this one as a frustrated user. So if we drill into like the waterfall of that page, now we can see all the resources requests that are being served as part of loading up that page. And so if we zoom in on that area a little bit, you can now see the backend call, which was that trace we were looking at earlier. So this is what we mean by kind of integrated observability, as I was kind of mentioning in that kind of high-level chart. So now we've seen a log linked to a trace, the trace linked to the distributed flow, the trace linked into the topology, and now back that trace in the context of the user session, as well as seeing what the user actually saw. So you can see it was just a couple clicks, but that's the real power of when you have a purpose-built platform. So since we saw a little bit of logs, and today's title was about logs, I want to talk a little bit about logs because we talked a bit about the data explosion. I won't really get into that too much more, but there's going to be a lot of logs, right? You have more services, more microservices, more things. There's going to be more logs. But now another dimension of this is the cost. So to store all these logs, to put them all together, to build indexes, say, on the attributes you want, to manage those logs, the human cost, the time, the opportunity cost to manage all that stuff, it's very high. And it's really at a point where you're making trade-offs. So do I want to do analysis on the data, and save the data and store it for long term, or rehydrate it and bring it back, or do I want to just do some rapid ad hoc stuff, whatever, right? Because it's too costly to store and manage all that stuff. So there's this pain point that's being felt. And so that's, what Dynatrace has done is we've just announced our new technology, which we call Grail, which is based on trying to bridge that gap of a data lakehouse where I want to do, just bring in unstructured data in a data lake. I'm sorry, that's a data lake, in a data warehouse where I have structured data and I do analysis. So a data lakehouse is the new underpinning core technology of Dynatrace, which we call Grail, which is purpose-built for this purpose. So it's not just for logs, even though we're starting with logs. All of the data in Dynatrace, metrics, events, traces, will all go to this architecture of a data lakehouse. This is a SaaS offering, and it's really addresses the volume problem. And you'll see that we're not going to be rehydrating log data. It's storing it at a low cost, and you'll see schema on read. There'll be no building of indexes because it's all schema on demand historically. You don't have to reload the data, and that's what's really powerful. And I think you'll see it in action, not just believe in me. And so the use cases, before I get into the next demo, are the things that we do with logs specifically is there's content in the log itself, and I want to pull out those values, right? There could be the product number or an error code or message. So it's not just a metric, it could just be an attribute, or it could be an actual number, something I want to make a number and quantify. That's also something I may want to pull out of it, make dashboards, share that type of data. And it's also, as we saw earlier, logs are great for troubleshooting, also application optimization, we look at trends. And then there's a lot of, audit and forensics, because logs could be firewall logs. Logs could be, other types of logs that help you in those types of use cases. So those are just some examples of, because we see, it's really actually interesting. We're not going to do it too much today, but this convergence of observability and security, because it's the same problem. Like where am I exposed with this, log4shell problem, for example? Like what I had an JNDI attack in my code. Did data leave the premises and back? Things like that. So just as a little footnote on Grail itself, these are just some characteristics of the underlying technology, but maybe the thing that you're going to see demoed is that middle square is just an instant query. So we're not going to reindex data to identify those attributes we want. We're not going to rehydrate data to reload it and have it pre-processed again. And therefore, we're not managing all these schemas and indexes offline and paying for all that storage costs. So it's all shifted now to a SaaS model where we can have a high volume ingest pipelines. So you can see here we have customers live, because it just went live with 10 terabytes of ingest, and because it just came out. And then in Q1, we're planned for 10 terabytes per tenant per day, and then with ongoing retention up to 3 years. So we're going to have petabytes of data storage with our log solution, and that same data stores for storage of the metrics and traces in the future. And then what's making it all possible is just a massive parallel processing architecture. So we've invested heavily in very large infrastructure. You're talking 96 core, terabyte memory, cache, all sorts of stuff, that if you were to kind of do that on your own, it'd be too cost prohibitive. So since we're talking about AWS, these are some examples just natively. We would bring obviously any other type of log source too, but since this is AWS, these are things that this is right up our help page on the documentation of the types of sources that we bring in kind of natively. And you can see in those columns, if you can read it, it's basically we're enriching it with those attributes I mentioned, like the entity, maybe the ARN, whatever attributes there are available. And then also entity linking if it's appropriate. So if the entity is already existing in our topology model, because you're from monitoring or the one agent, it would automatically link those logs that you saw in that other demo. So speaking of demos, I'll go to the next one, which is operational excellence. So you can read the tagline at the top, but really what I want to show is now that we have this underlying topology, the logs, the metrics, we want the AI engine of Dynatrace to now showcase how we can get to root cause and help us with the operational aspects. So instead of trying to piece together dashboards and things like that, this is just a core capability of Dynatrace. And the idea is that we're going to reduce our mean time to identification and resolution by letting automation do it for us. So here, what we're looking at is sort of the culmination of that, which is the Dynatrace problem card. So what Dynatrace, what's different is that we're not saying, here's an alert, my CPU is 20% alert. A problem card is a window of time where things are being impacted. So at the top, you can see a summary of the impacted applications, services, and infrastructure, and that's being updated continuously for the duration of this impact. And as you saw, we link the transactions back to the user experience and vice versa. We can now derive then who are the impacted users, what are the entry points in the system, whether it's mobile, synthetic, or real, to show a business impact kind of view automatically. And then if we go down here, because the way that people were coming in, there could be different sources, and as I mentioned, so these are representing applications essentially, or the entry point of the problem, and of course each of those may have application owners, and so that's aggregated into view. But how it's really doing it, and this is what's kind of cool about this next part, this is what's called the, if you can't read that, it says visual resolution or problem evolution page. So what we're seeing here, and it's going to be animated, so Dynatrace is capturing essentially the snapshots it's analyzing in time. And if you can kind of see down in there, you'll see, hey, there's a response time problem. Hey, I'm seeing high error rates, and those are color coding there on the left. So that whole left-hand side topology is being built dynamically because it says, hey, I'm entity number one. Who calls me? Who do I call? And so on. And it has built in a causation engine to say, oh, if I have a port failure on this and it's something on that, that's a cause and effect relationship. So through all those cause and effects relationships, it's going to derive the root cause, which I'll talk about in a second. But what I this is the way the order this demo was. Like, so what it also does is the problem is impacting service level objectives, and that's what I just clicked into another page. So this service level objective is any metric in Dynatrace can be into, an availability metric, a performance metric like response time, or it could be a business metric. Any metric in Dynatrace can be formulated into just basically something divided by something is a rate. And so that rate over some time frame is your SLO. And you can have a series of these things. So in this case, multiple SLOs were affected as a result of this problem. And why that's important is because now I can prioritize things. So if I have a problem that doesn't affect service levels, I'll probably treat that as less of a priority than one that affects a whole bunch of service levels. So now back to the root cause. I know I can't stop the thing. So back to the root cause. So as it went through that visual resolution path, it said the root cause was this particular service. Everything else was a symptom. This guy is the root cause. So in here, it's a failure rate. So we're starting to see some summary information, the error rate itself. The next little block is, there's a couple entry points from the mobile app as well as the web app. That's kind of the breakdown of some of those calls. If it goes a little further, we can see that there's, this particular package was the cause of the error, and we could get into more details of that, but what I wanted to show you was the logs. So now here are all the logs in this time frame of the problem associated with this service that was the root cause of the problem. So again, think about the speed, that you got at your fingertips. You got a problem card, here's a business impact, I can prioritize it, one click, I want to jump into logs and see what's up. And that's what we have here. But since this is just kind of a lot of logs to look at, we're going to go back to the log analysis view. So before we were doing like a simple view of like filter, 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 but what Grail introduces is what's called the Dynatrace query language. So this would be our unifying language to access all the data in the data lakehouse. And so you can see here for this log detail on the right, many of these messages are type info. So just to show you a quickie, we can say this is fetch logs filter on this particular entity. And now I'm going to filter the log level equal error and rerun my query. So very simple. They can follow that. But that just kind of starts to show you the syntax. So each thing is like a pipe delimited kind of set of commands. It's like fetch, filter, do something. I'll show you more examples. So in this case, here's our specific log content, which has a bunch of stuff, but the one I really want is the verbiage after easy travel service, that stuff in red. So I want to pull that out. So if I had another tool, I might, or maybe something else, I may have to have built an index before this log was even ingested to say, all right, this is the string of this particular log, pull that out, allow me to have that as some sort of attribute that I can then look at. But with this, we don't have to do that. So what you'll see here, will be pasting in another command onto this string, and now what it's done is said, okay, there's the message you can see on that column. So how did it get that? I kind of zoom in. But the command that did it was parse the content, and you can see it's a simplified regex. So we're not using regex, so Dynatrace is part of the query language. Just optimize this to say I have some line data, look for the word easy travel service, a space, and then the next thing you see, call that a variable or an attribute called message. And so that's what it was doing. It was saying, filter this out. I want these fields. I want to parse out, get something called message. And you can see this next line is summarize command. So I want to count the log rows and group it by message. And so now you can see all that log data. I have 198 rows of that message. And so that was all done just through a couple commands that I think are pretty easy to understand. So I can change my time frame, look back in time, maybe see if there's some more messages of this type. And now another row kind of came up. So this is all what I meant by schema on read. So this was not reloaded. It wasn't indexed in advance. And that's really what you're going to see here. And that becomes very powerful. And I'm going to build on that in the next demo here. So we look at reliability, because that was really a troubleshooting example. So the next pillar was about, I want to understand and do some analysis on my application. One of the best practices of WellArchitected is that you get these metrics for investigation and analysis and things like that. So not all those use cases, the things you want are known up front. That's the challenge of logs. Like you don't know what's in the logs, you don't know what you need, you have a request to do something. And so the next set of demos are going to show kind of what you can do. So if we go back to that example of Kubernetes where I had an error, the front-end service, the production Kubernetes namespace, we switched to that advanced mode or the query language mode, so you can see the syntax is just a filter statement. that's kind of optimized because now it's just one row. And if I change the, to say, hey, these are the fields I just want the content field versus all this other stuff. Now I'm just looking at that one content field. So this is now the message of this example. And you can see inside of this content string is something like this error code. I want that. I want the description field. I want that. So that's what that's what this demo is going to show you. Like, how would I get that with the query language? So we paste the example here. And you'll see, now it's aggregated with the error code, the error description, and the timestamp all pulled out of the log. And it's made possible because of those parse commands. So it wasn't, again, pre-indexed up front. I didn't have to reload my data. It's schema on read. It went back in time. And so now you'll see, I think I pasted in another example. We can do that aggregation. So now I could say same thing. Give me a count by code and description. And so now there's my code, there's my description and count. And so now I have a quick little analysis, from my logs. So it's pretty good. So if I wanted to share this information, there's this one way, maybe you have Slack or Microsoft Teams or something, whip it out into a CSV file. Here's your data, share that as a quick ad hoc report. So that's, a use case. So here's another example where here's a different log in a different format. So this one has like a comma-separated key-value pair, as you can see, and I want this stuff, user ID, product quantity. And you'll see with quantity, I want to do something with that quantity because I want to count. That's what the example is going to show. I ultimately want to count the quantity across all these logs, treat it as a metric, not just an attribute. So here, that parse command is taking place. So I'm parsing out, give me the product ID, give me the quantity, and then convert it into an integer. And then that's the result. I could get the product ID. But now that is not just a number. I've converted, you can saw in the syntax, it got converted into an integer. And now I could say, let me summarize, do a sum of that field, rename it to quantity, and then group it by product. And then give me the top 20 in descending order. So if you're familiar with SQL, this sort of feels like SQL, right? But now you're doing this against a log, and you're doing it without having to define any of the indexes up front. And then so here you could visualize that particular query and maybe pin it to a dashboard. Maybe this particular query is something you want to, get the top 20 volume just on a dashboard for some reason, right? So you can easily put this, combine that with other tiles of stuff in a Dynatrace dashboard. So then maybe the last example is another log where the data here is in JSON format. So just filtering on that content field so you can see it. And then this is often what you see in a lot of logs too, especially with newer stuff. So JSON would have a lot of attributes. It also could be nested. So again, if you had to predefine all your indexes up front of the stuff you wanted, that takes time. You have to maintain it. You have to build those indexes. You have to reload your data. But here in this example, we have another feature to convert the entire content into a JSON object. So like before, we converted the field into an integer. There's a whole bunch of different things you can do. One of them is JSON. And now I can say JSON, bracket, attribute name, call that a field, and now do the same thing. Summarize the count of the rows. In this case, group it by an hourly buckets or bins. And now I can see count message by time frame of an hour bucket. And then this could be done, something could be done with that. So that was really my last demo of this. So hopefully I think between, if I go back to bring it up a little bit with Dynatrace, we're bringing in logs, metros, and traces for sure. We bring it all in, and we're adding this topology, the context, the user behavior, the code level insights, the metadata. We didn't even talk about security, but there's a whole other security aspect to this too. And we're feeding it in through, high volume ways of ingesting this data. So our one agent is very, very established, very mature. And any logs that are on a particular resource, it would automatically see, enrich it, and forward it on. You can also have an API, like that's kind of how CloudWatch metrics and logs come in. They can come in through an API. And then obviously open telemetry is full support for that. And also we have a lot of ecosystem partners that also send us data through our APIs to ingest data to Dynatrace. And this is all going to go into Grail. So Grail is not a separate thing. It's like the foundational data lakehouse that's now going to underpin Dynatrace. For all the data. And then it gets layered on, as I showed with the AI engine. And then that Smartscape is also kind of how we visualize the topology, and then it kind of opens up these use cases. So this kind of in a nutshell, that's a good screenshot for what Dynatrace is, kind of left to right. So it's really just key takeaways for us. I know, we have a data lakehouse woven into the architecture. We have auto discovery of the entities and relationships with a causation AI engine kind of called Davis is the name of our AI engine. And it's an all-in-one platform. So I hope you see that it's like not like 3 different modules and whatever. It's like completely integrated, purpose-built solution for these types of problems. And now with the ability of DQL, or Dynatrace Query Language, we get this deep analytics ability in a unified language as well. So I'm happy to stick around for some questions if you have it. I know it's the end of the show, but just sort of my closing thing is just, we're a strong partner with AWS. We have a lot of native integrations, and I think together, we're better for you guys. We have a marketplace listing, and that's maybe my takeaways. So we have a Grail resource page. You can welcome take a screenshot of that. But this is just, dynatrace.com/Grail, or resources/Grail is what that's going to go to. And then through the marketplace, you can spin up on your account, and it'll automatically spin up a SaaS tenant. And then you can, that wizard will also start you up with CloudWatch metrics integrations, and then the full trial is, actually that's a pay-as-you-go. So you have the pay-as-you-go for spinning up the agents. So the expo floor is over, but that was our booth. So I know some of you guys came by, so thank you for that. Hope you got a T-shirt or won something, but we appreciate you coming by our booth as well. So that's my contact information. You're welcome to reach out to me. There's my email. I'm on LinkedIn. It's just Rob Jan, based out of Boston. So if you're in Boston area, give us a shout out. Our headquarters is there. Happy to give you a tour. But if there's any questions, I'm happy to stick around, or you can come up to me afterwards. But thank you all for your time. I know it's the end of a long week, so thank you guys.